Welcome to Mrs. Merkel's Trig class. Let's start with a prayer. In the name of the Father, and the Son, and the Holy Spirit. Amen. Ave Maria, gratia plena, Dominus tecum, benedicta tu in mulieribus, et benedictus fructus ventris tui, Iesus. Sancta Maria, Mater Dei, ora pro nobis peccatoribus, nunc et in hora mortis nostrae. Amen. In nomine Patri et Filii et Spiritus Sancti. Amen. Okay, let's get started. We are talking circular functions today. So I'm on page 613, 13.2, circular functions. So let's take a look at what we have to say here. All right, so remember when we did trig functions, we had the unit circle and we had a point and we could find the angle to that point, okay? There was the angle and then we found all of the trig functions. Well, here's the thing. S can represent a number and not an angle, okay? So S goes from here to the point XY, okay? And the reason that we're doing this is because sometimes you can have an equation, like there's an equation of a wave where y is equal to 2.5 sine of 0.03x, where y is the height of the wave and x is the horizontal distance of the wave. This equation describes an ocean wave, and it follows this equation, where sine is not an angle. It's not that sine's not an angle. What I was saying is that there's no theta involved here. There's no angle involved. If you look at the equation of line voltage, the voltage is equal to 170 cos 120 pi t, and t is time in seconds. So S is not an angle. That's what's most important, is that these circular functions, we now don't have an angle in degrees like we did before, okay? So, but what they do is, what the math department did is they use the unit circle. Now, the unit circle comes from the fact that this is the point x is equal to 1, y is equal to 0. This is the point y is equal to 1, x is equal to 0, negative 1, 0, and so forth, all the way around. That's what they mean by the unit circle. And you're going to learn much more about the unit circle in pre-calc, okay? So what they did is they used the unit circle and the fact that we know that x squared plus y squared is equal to 1, okay? So you're going to start at A right here, and you're going to go counterclockwise. If you start at A and go counterclockwise, S is going to be positive, okay? If you go clockwise, S will be negative. That's just a definition for math, okay? So for S, if you go counterclockwise, S is positive. If you go clockwise, S is negative, okay? All right, let's see what all this means, because I know it's a lot to throw at you, something that we haven't really even talked about before. But let's take a look here. I'm going to make sure both of these are in my screen and move it over a little. Okay, so using the fact that this is the unit circle and the fact that x squared plus y squared is equal to 1, the math department defined these things, I mean, not defined, derived. They found that the sine of S is equal to y, okay? So what that means is this is the point xy, the sine of S is equal to y, okay? So the cosecant of S, it's just, remember, the cosecant is 1 over the sine. So all you have to do is flip it, okay? So if the sine of S is y, the cosecant of S is 1 over y, okay? The cosine of S is equal to x. So for the secant, we just flip that and you get 1 over x. And now for the tangent of S is equal to, remember, the tangent is the sine over the cosine. So the tangent is equal to y over x. Okay, and for cotangent, you could do that where you say cosine over sine, but basically each one of these, it just basically flips it. See how sine is y, cosine is 1 over y, x 1 over x, this is y over x, and this is x over y, okay? And in the book, they just have to make sure that s is not equal to 0 because we can't have any zeros in our denominator, okay? So this is important. This is what you need to know, okay? All right, so now let's take a look, though. circular functions and trig functions are completely analogous. Okay, and what that means is it's what's true for trig functions is also true for circular functions. But let's see how they relate to each other in this diagram. Okay, now remember how I said we didn't have theta, we didn't have an angle? Well, actually, the sine of s is equal to the sine of theta as long as theta is in radians. So we do have an angle, but the angle must be in radians. And the sine of s is equal to the sine of theta as long as theta is in radians. And we've been talking a little bit about radians. We're not going to go too deeply into this. This is just an initial investigation into circular functions. You'll definitely do more into pre-calc when you get into pre-calc. Okay, so let's take a look at what we're going to do with all of this information now. Okay, so we're going to need these. All right. So what we need to do now is we need to look at our circle here, okay? First of all, before we go any further, before we go to an example, what I want to talk about is I want to talk about the quadrants here for a second, okay? Because sometimes when they talk about angles in radian measure, we need to look at this and see where each of the quadrants goes to, okay? So if you remember from before, we know that there is 2 pi radians is equal to 360 degrees. So you look at the point right here on our circle here. If we go all the way around, that is 2 pi, okay? So if you go here, to this point here, that's, think about it, 90 and 90 and another 90 is equal to 270. This point here is 3 pi over 2, okay? Pi radians is equal to 180 degrees, so this is pi. And pi over 2 is 90, so this is pi over 2. So if we say that it's between 0 and pi over 2, that just means it's between 0 and 90 degrees. If we say our point is between pi over 2 and pi, that means our point is in our second quadrant. That just helps us to define the quadrants if we know these measures, okay? All right, let's take a look now at an example. So this will help you with your homework. So they gave us an example here where they gave us point P is equal to -3/5. That is the x coordinate. And 4/5 is the y. I like to label the x and the y. That way, for some reason, you don't make a mistake. I like to write it right over top. If you have another color, that works out good too. All right, so let's take a look. We're going to use this that the sine of s is equal to y. So the sine of s is equal to y. If we go up here, y is equal to 4/5. So that's the answer. The sine of s is equal to 4/5. Okay? The cosecant of s is 1/y. All that means is you flip it. Okay? So if the sine is 4/5, the cosecant is 5/4. Okay? Let's take a look at the cosine now. The cosine of s is equal to x. Okay? Here in our example, x is equal to -3/5. So for the secant, it's going to be -5/3. It doesn't matter where the negative sign is as long as it's either in the numerator or denominator, as long as it's not in both. Okay? So let's take a look at our last function. So we're looking at all 6 of the trig functions for our circular function. And now let's take a look at the tangent. Now the tangent's a little bit more complicated because the tangent is y over x. Okay, so the tangent is 4/5 over -3/5. All right, we have a fraction divided by a fraction. So when you have a fraction divided by a fraction, we're going to keep the first fraction, which is 4/5. We're going to change it from division to multiplication, and we're going to flip our second fraction. So the second fraction becomes -5/3. Okay, so we do all of that math. We cancel the 5's out. Okay, and you get the tangent of s is equal to -4/3. We did all that work for the tangent, so for the cotangent, all we have to do is flip it. The cotangent of s is equal to 1 over the tangent of s, which is equal to 3 over -4. Okay, so there's going to be problems on this on the homework. Just follow this exactly. All right, and it shouldn't be too bad. Now, the directions, sometimes if they tell you they want an exact value, you have to leave it as a fraction, okay? Because think about it. If you were to put in 4, let's just look at this here for a quick second. 4 divided by 3 in your calculator is 1.3 repeating. So if you write that as a decimal, you're in essence rounding, okay? So when the directions in the book say they want an exact value, you must leave it as a fraction. You can't write it as a decimal, okay? Now let's take a look at the next sheet here. Next sheet says, now this is the second thing for second set in your homework. I'm on page 617. I'm going to look at number 6. It says, find the sine, cosine, and tangent of each number to 4 decimal places. Okay, so what that means is we're not going to leave it as a fraction. We're actually going to use our calculator and find the answer. So number 6, they want me to find the sine, the cosine, and the tangent of 1.4. Now remember what we had before. Let me see here. Where is it? Oh, here we go. Oh, I think I wrote it right here. All right, the sine of S is equal to the sine of theta when theta is in radians, okay? So what we're gonna do, and I wanna show you how to do this. I don't know if you can see this. Let me see if I can get cut closer, if you can see it. Okay, now if you have the Texas Instrument like I do, to change from degrees to radians, you have to see there's a DRG key right here. Press the DRG key. Then you'll see degrees, radians, and something I've never used before, okay? My calculator is already in radians, but if I move the arrow, see the lines are under degrees. And if I move the arrow again, the lines are under radians, okay? So in order to do these problems, you need to put your calculator into radians, okay? So let's take a look. So I just showed you how to put your calculator into radians. Now let's take a look. So the sine of 1.4. So all you need to do is you put, now we know our calculator is in radians. The sine of 1.4, oops, why did I put a 1? Sine of 1.4 is equal to, now it said to 4 decimal places. So if you look at this, the sine of 1.4 is 0.9854. That's what they're looking for, okay? Just make sure that whether it be physics or math, sometimes your calculator will need to be in degrees and sometimes it'll be in radians, and you have to make sure that it's in the correct, because it will give you the wrong, it'll still give you an answer, it'll just give you the wrong answer if you're not in the correct, whether it be degrees and radians, okay? So if we look at the cosine of 1.4, that is 0.1700, and the tangent of 1.4 is 5.7979, okay? So your homework is going to have problems, so don't read too much into this. Just try your best to understand circular functions. It's our first look at it, and hopefully it'll give you a little bit of a better understanding for when you guys see it in pre-calc, okay? So the homework is going to give you problems, page 617, 1 to 7 odd, okay? There's going to be some problems like this where we need to find the exact value, and there's going to be some problems like this where we need to round to 4 decimal places. Okay, so practice with that and see how it is, and that is actually all we're going to do with the trig functions and circular functions. So we'll on to chapter 8 tomorrow. All right, sounds good. I think that's all I have for you today. You guys have a great day. God bless you, and we'll see you tomorrow.